Hello everyone, I am BVLP, your physics teacher, and welcome back to my channel Alpha Beta Gamma. From this video, I am going to start a new chapter, Ray Optics. Ray optics is a branch, a sub branch of optics. Optics is a branch of physics which deals with complete nature and characteristics of light and its applications. And now I am going to start lesson 1. Now, let us see. So, what points to be discussed in this lesson? We are going to discuss 2 points in this lesson. The introduction to ray optics. In this point, we are going to discuss what is ray optics and what are the applications and that are going to be studied and what are the properties of the light rays. And also, one of the properties of the light ray, a reflection of light. So, ray optics is a branch of optics which deals with the nature of light based on Newton's theory. Before starting the ray optics, I would like to explain what is light actually. Light is a form of energy, a radiation which can travel through vacuum also. When light travels through a vacuum or air or in any other medium, electric and magnetic vibrations are produced perpendicular to each other. Therefore, it is an electromagnetic radiation. An object or a body which emits light is known as source of light. Naturally, all the stars, including the sun, emit light themselves. The reason is continuous nuclear reactions occurring in the stars, including the sun, release huge amount of energy which consists brightness and high intensity, which is known as light. This light can travel through vacuum with a high speed. Therefore, all the stars are self-luminous. And we have other sources also. We have other sources of light like candle, electric bulb, and lamp, oil lamps like that. So, when light strikes an object, it produces heat, and we can feel the intensity of light also. As per Isaac Newton's study, he found that the visible light, which can be seen by human eye, consists 7 colors and which is in white color. It means white light is a mixture of 7 colors. So we are going to learn this point in the next coming lessons here. So this is about the origin of light. Light is emitted or released by a of object which is called a source of light. Stars are natural sources of light, and we have other sources also like electric bulb, torch, candle, and oil lamp like that here. So, coming to the substances which are classified into 3 groups as per the propagation of light, whether the light can penetrate or propagate through them or not. All the substances are classified into 3 groups. Number 1, opaque substances. These substances like wall, plastic, wood, and human body. We have many other substances also which will not allow the light to pass through them. It means the light could not travel or propagate through these substances which are called opaque substances. Number 2, transparent substances. These substances are colorless and the light can freely transmitted through these substances, and the velocity of the light depends upon the substance or the medium. For example, glass, air, water are the examples for transparent substances. Other than these two, we have a third category which is called transient substance. This substance does not allow the light completely to travel or propagate through it. It partially allows the light to pass through it. This is called transient substance. We have a few examples: wax paper and frosted glass. Here, the examples of transient substances. So, based on the propagation, all the substances are categorized into three: opaque, transparent, and transient substances. Here, coming to ray optics, as I told, this is a sub branch of optics which deals with the nature of light based on Newton's theory. So, Newton's theory and his experiments, they results that the light consists of many number of small invisible particles, and he named them as corpuscles. These corpuscles travel in vacuum or in air with a speed 3 multiplied by 10 to the power of 10 centimeters per second, or 3 multiplied by 10 to the power of 8 meters per second. So, in the air or in the vacuum, the speed of the light is denoted by c, 3 multiplied by 10 to the power of 10 or 10 to the power of 8 meters per second. And these particles, which are known as Newton's corpuscles, they travel in a straight line, which is called light ray. A ray is an imaginary path of light particle and which is indicated by an arrow mark. So light ray is indicated represented by an arrow mark which represents the direction of the light. So if for our convenience, we always represent the direction of the light from left to right here. So here the light particles exhibit some important properties. As per Newton's theory, so light when it strikes an opaque substance, it is sent back, which is called reflection. And also when light particles travel from one medium to another medium, from one substance to another transparent substance, then they exhibit the property which is called refraction of light. So when the light changes its medium, then velocity of the light is also changed. It means the velocity of light v in any substance, transparent substance, which is called a medium, is always less than c. It means the velocity of light is maximum in vacuum or air. In any other medium, the velocity of light v is always less than that of c here. This is about the light particles. So in this ray optics, we are going to study a few properties exhibited by light rays. Number one, reflection. 2, refraction. 3, total internal reflection. 4, dispersion and scattering. So, in this ray optics, apart from these properties, we are going to study mirrors, system of mirrors and lenses, where we use all these in optical instruments like microscopes and telescopes, and also the defects which occur in the image system of lenses called aberrations in ray optics. So ray optics is a branch of physics which deals with light particles based on Newton's corpuscles theory, and in this ray optics we are going to study the properties of reflection, refraction, total internal reflection, dispersion and scattering, and also the system of mirrors and lenses and the defects occurring in the lenses called aberrations. So coming to the second point in this lesson, this is the property of reflection of light. So this property is exhibited by the light rays when they strike an opaque substance. As I told, opaque substance does not allow the light to pass through it. And also, I gave you the examples: wall, human hand or body, and wood, plastic, etc. So, when light strikes the surface of opaque substance at any direction, then it is not allowed to pass through that, so it is sent back in other direction. It means the light ray is sent back in other direction here. So this is called reflection, sending back of light when it strikes an opaque substance is called a reflection of light here. Here we have an opaque substance on which light incidents here. This is the torch which emits the light. The light strikes the opaque substance, but it is sent back in other direction here. This is a reflection of light. During this property, during this reflection of light, what are the conditions or the characteristics or the properties followed by the light ray? So this is a ray diagram which represents the reflection of light. For our convenience, we have considered a mirror. Mirror is a reflecting surface. And when light strikes the mirror, the reflecting surface sends back the light. So reflection of the light is exhibited. And hence we can see our image in a mirror. So using this mirror, I am going to explain you the property of reflection. Here, a light which strikes the surface of the reflecting surface of the mirror, this is called incident ray. When it strikes at a point, and we can draw a perpendicular line to the surface, which is known as normal. So we can clearly observe that as the mirror does not allow the light and the light could not pass through the mirror, it is sent back. It means it is reflected. So the light is reflected in this direction. So it means the reflected light has a different direction. It means the light is reflected in a different direction here. To know the direction of the light ray, we have to clearly observe this complete diagram here. When you observe this diagram, so this is the normal, a perpendicular line which is drawn at the point of incidence of light. And we can observe that the incident light and the reflected light are on either side of the normal. And also we can observe two different angles. Number one, the angle between the normal and the incident light, which is known as angle of incidence. Number two, angle between the normal and the reflected light, which is known as angle of reflection here. So two angles are observed here. Number one, angle of incidence, which is also denoted by I, and angle of reflection, which is denoted by R. And if you observe, these two angles are equal to each other. So this is the property of reflection here. So keenly observing this here, the incident light, reflected light are on either side of the normal in the same medium, and also they are in the same plane including with the normal. And angles, both the angles, angle of incidence and angle of reflection are equal to each other. These are the laws of reflection. So here we have summarized the laws of reflection. Number one, the light does not change its medium during the reflection. It means the incident light and the reflected light both are in the same medium along with the normal. And the second point is the incident light and the reflected light with the normal all the three are in the same plane, and the incident light and the reflected light are on either side of the normal. And the third point is the angle of incidence and the angle of reflection are both are equal to each other. And the next question is the reflection property of reflection and the applications where it can be applied. It can be applied in various fields, in various sectors. So here we have a few natural applications here. So without reflection, if light does not obey the property of reflection, the images and the shadows could not be formed. It means the images and the shadows are formed only due to the reflection. And one more important significant property of the light reflection is vision power. So we could see or we could observe, and we have the vision power only due to reflection. The light is reflected from any substance, any object, and that can be seen by us or by human. So this is only due to reflection. If there is no reflection of light, then the object could not be seen. If the light is not reflected by an object, then the object could not be seen. So the images, the shadows, and the vision power are due to reflection only. And in astronomical telescopes, the property of reflection is the basic principle to construct astronomical telescope. And also during the photosynthesis, the leaves gets the color green color, and also all the objects, all the bodies get the color due to reflection. When white light strikes the object, it absorbs all the colors and reflects a particular color. Then this object is seen in that particular color. For example, if an object is seen in blue in color, then why it seems to be blue in color? The reason is when white light strikes on that object, all the colors are absorbed by the object except blue. So it reflects the blue color. Hence, it seems to be blue in color. So this is the reason why all the colors, all the objects get the color. There are so many applications of reflection in um, um, in more cinematography, etc. So we will discuss those applications later along with other applications also, because reflection and the second and one more application, refraction, both properties are fundamental properties, and they are connected with other properties are also. It means all the other properties are, so they are based on reflection and refraction only. So this is about the reflection, sending back of light by an opaque substance. This is the reflection. So in the next lesson, we are going to learn refraction and its characteristics. Till then, we'll have a leave. Thank you for watching my video.